Hello students, welcome to our channel. So in today's class we are going to discuss about the chapter 10 in grade 12 cbse. That's the haloalkanes and haloarenes. Okay, haloalkanes and haloarenes. So first, before entering to this chapter, you have to know what is that haloalkanes and what is that haloarenes. Alkanes, you know that. So what is that alkanes? In the organic chemistry we have learned. What is that in the carbon compounds? Methane, ethane, propane, butane. Okay, that suffix ane. So these all are that alkanes. Okay, which has a single bond in their structure. Haloalkanes. So what is the meaning of haloalkanes? So in that alkane group, there will be the halogens also. So what is that halogens? Group 17 elements are called halogens. Fluorine, chlorine, bromine, iodine. Okay, these all are called halogens. So the alkane structure which has the halogens, it is called haloalkanes. And haloarenes, aryl group. Okay. So what is that? Benzene ring structure, aromatic structure. Okay, so that is arene. And next with the that aromatic structure which has that the halogens are called, that is haloarenes. This is just a simple explanation about the haloalkanes and haloarenes. Only the title explanation. So at the end of this chapter, what are the things you will come to know that you have to know first? So what is the objective? So here I have taken your NCERT book itself. So you have to learn line by line first. So here objectives, what are the things after studying this unit you will be able to name haloalkanes. So if they give any structure, you have to write the name and you have to write the IUPAC name, common name. So that you will learn in this. Okay, especially about that haloalkanes and haloarenes. So you in this place you can recall what are the things you have learned in grade 11 in organic chemistry. And in grade 10 you have learned only one chapter, that is carbon and compounds. In that it was the basic when you have learned, that is alkane, alkene, alkyne and halogens. Yes? Okay, we'll come to the point. After studying this unit, you will be able to name haloalkanes and haloarenes according to the IUPAC system of nomenclature. So from the grade 10 itself we are writing, from the carbon compound lesson onwards we are writing what is the common name, what is the IUPAC name. Yes. So and the next, so first things clear, you are going to give the name, and the second you are going to describe, at the end of this chapter you are going to describe the reactions involved in the preparation of haloalkanes and haloarenes and understand various reactions that they undergo. So what are the reactions involved in the preparation of haloalkanes and haloarenes? Okay. Next you are going to correlate the structures. So what is the difference between the haloalkane structure and haloarene structure? So where is the structural changes happen? That things you are going to look up at. Okay, you are going to look at that, the structure. Next, use stereochemistry as a tool for understanding the reaction mechanism. So reaction mechanism, you have learnt more mechanism, SN1, SN2, E1, E2. Yes. So here what are the different mechanisms you are going to learn, we will discuss. And the next, appreciate the applications of organometallic compounds. So every chapter this point we have to be clear. Applications. Why are we learning this? What is the application of this chapter? Everything you have to know. So okay, appreciate the applications of organometallic compounds. Okay, so we have learnt all the haloalkanes and haloarenes in this chapter. So this is the application. Where are we using this application? Everything we have to know. Okay, next, at the end of this chapter you will be able to highlight the environmental effects of polyhalogen compounds. So poly means many. So many halogen compounds, how does it affect the environment? Okay, so now we'll enter into the introduction of this chapter. The first page, they have given the clear application based few things. What is it? Haloalkanes. What is haloarenes? Yes. Okay, look at that. Halogenated compounds persist in the environment due to their resistance to breakdown by soil bacteria. Okay, so persist means what is that? It is existing continuously. Okay, next, the replacement of hydrogen atoms in aliphatic or aromatic hydrocarbon. Example, aliphatic hydrocarbon I will give, that is methane or ethane. So what is the structure for ethane? You will write CH3, CH2, CH3, CH3, CH3 you will write, alright, 2 carbon atoms and with the 6 hydrogen atoms. When you replace one hydrogen atom, so how will be that? C2H5, C2H6 now change to C2H5. Okay, so that instead of that replaced hydrogen atom, you are going to add one halogen atom. So now ethane changes to ethyl chloride. This is haloalkanes. Okay, so look at that. The replacement of hydrogen atoms in an aliphatic or aromatic hydrocarbon by halogen atoms results in the formation of alkyl halide, haloalkane, and aryl halide, haloarene. Okay, so the structures we will see in the next part. Okay, next, haloalkanes contain. So haloalkanes, from the name itself you can say what are the components are there. Haloalkanes, definitely halogen group is there and with the alkane group. Okay, alkane in the sense what is that? It is the sp3 hybridized carbon atoms. So you know that what are the hybridized different hybridized atom? sp, sp3, sp2, have to know. Okay, so for the alkanes it is sp3 hybridized carbon atom. Okay, so next, whereas haloarenes contain halogen atoms attached to the sp2 hybridized of an aryl group. Many halogen containing organic compounds occur in nature. Some of these are clinically useful. Okay, this is the application based, you have to learn. Okay, clinically useful. These classes of compounds find wide applications in industry as well as in your day-to-day life. So they are used as solvents for the relatively non-polar compounds and as starting materials for the synthesis of organic compounds. Okay, so these things will come under the application based. So it is important, have to learn. Okay, so they are used as solvents, so which is used to dissolve for relatively non-polar compounds. And so you have learnt about the polar compounds and non-polar compounds. Yes, so here and as a starting materials for the synthesis of wide range of organic compounds. So many organic compounds can be synthesized from this haloalkanes and haloarenes. So we are going to learn this. Next, chlorine containing antibiotic. So here they have given that is chloramphenicol. Here look at that, chloramphenicol. So here if you see that chlorine group is there, phenyl group is there, alcohol group is there. So look at that, phenicol, OL ends with OL, it's alcohol, phenyl, and next chlorine group. So produced by microorganisms is very effective for the treatment of typhoid fever. Our body produces iodine. So it is happening in our body, it contains the hormone. So what is the hormone? That is thyroxine. So the deficiency of which causes a disease called goiter. So you have learned depth in biology too. Synthetic halogen compounds. So synthetic halogen compounds. So it's a synthesized. We have synthesized from the haloalkanes, haloarenes. Okay. Yes, here we have learnt one point. So it is used to synthesize of many organic compounds. Compounds wise, chloroquine. Okay, so what is the purpose of chloroquine? For the treatment of malaria. Okay, next, halothane is used for anesthetic during surgery. Okay, certain fully fluorinated compounds are being considered as the potential blood substitutes in surgery. Okay, so there is the major relation between the chemistry and the medical thing. Okay, in everyday life we are using that chemistry. Yes, so from the morning, when you are taking that brush, it starts the chemistry. Okay, so you can see in case if you are going to buy any medical strips, you can see at the back the what are the things are present there. So there you can see all these things and the components. Okay, next, so this is the small introduction about haloalkanes and haloarenes. Okay, so now in the future video we will discuss about the preparation, properties and its uses, and where are we using based on the application we will see that. Okay, thank you, we'll see in the next video.